Good afternoon. So today we will discuss open channel hydraulics. So open channel flow implies a flow in a channel open to the atmosphere, but flow in a conduit is also open flow if the liquid does not fill the conduit completely, and thus there is a free surface. Okay, open channel compared to our previous topic, which is the flow in pipes. So comparatively, we will still use the same concepts. We will still use the continuity equation in the ah, mass flow continuity equation. We will still use the concepts in friction as the resisting factor in the flow, but there are things that are different. So unlike the flow in pipes, open channel doesn't have a gauge pressure. Um, it doesn't have a gauge pressure present in the flow because the surface or the water surface is exposed to the atmosphere, or in the first place there is a water surface compared to flow in pipes that there is no water surface, right? So there are also uh, open channels that is flowing in a pipe, but we still considered it as open channel because there is a free surface in it. So for example, water that is flowing in a culvert. So culvert is considered as a pipe. It's RCPC, reinforced uh, concrete culvert pipe, but we consider it in our analysis as uh, an open channel because it has, or most of the flow in the pipes has a free surface, and that free surface is exposed to atmospheric pressure. So an open channel flow involves liquid, mm, typically water or wastewater, and exposed to a gas, usually air, which is at atmospheric pressure. Flow in pipes is driven by gravity and or pressure difference, whereas flow in an open channel is driven naturally by gravity. So there's no gauge pressure involved. Water flow in a river, for example, is driven by the upstream and downstream elevation difference. So the flow rate in an open channel is established by the dynamic balance between gravity and friction. So the reason why water will flow in an open channel, it's because of the difference in elevation, difference in slope gradient, and compared to pipes, there are situations that the pipe is totally horizontal. There's no difference in its elevation from point A to point B, but there's a difference in pressure. So mao na siya ang difference between open channel and pipe. The main difference is in pipe, closed pipe, there is a pressure involved, whereas in an open channel, wala siya pressure involved. So water flow in a river, for example, is driven by upstream and downstream elevation difference. So flow rate in an open channel is established by the dynamic balance between gravity and friction. So the reason why there is a flow is because of the gravity, and the reason why there is a resistance in flow because of the friction. So but the height of the free surface of the channel bottom and thus all the dimensions of the flow cross section along the channel are not known. so they can change along the average flow velocity. So the the vertical distance between the free surface and the channel bottom, in most cases in the natural flow, in the natural waterway, are not known. So most of the time, mao na ang atong isolve, or we can measure it physically, but it is a dynamic parameter, so it will change depending on the velocity of the flow. So mao lang siya ang nakalahi, whereas in the pipe, so wala man siya, there's no depth of the flow because the pipe is completely filled with the fluid. In an open channel, the flow velocity is zero uh, at the side and bottom surface. So zero ang flow at this portion here. So na siya, or assumed as zero. Theoretically zero daw na siya, the flow on the side. Then zero, theoretically zero, then theoretically it will increase as it will uh, get farther from this side. So magkadako ang velocity. This is actually the velocity gradient of the flow in a typical trapezoidal channel. Zero ang flow because of the no slip condition in the channel. So I think we discussed that earlier. We discussed that in early part of this course, and on the I think on the previous topic, because of the no slip condition, because of the uh, resistance of the friction, the resistance between the water and the wall of the channel. So the wall shear stress, this one, varies along the weighted perimeter at a given cross section and offers resistance to the flow. The magnitude of this resistance depends on the viscosity of the fluid as well as the velocity gradient at the wall surface, which in turn depend on the wall roughness. So yeah, the resistance, the friction resistance depends on different factors such as the viscosity of the fluid. So it actually depends on the type of the fluid, viscosity of the fluid, uh, velocity gradients, and of course the wall surface, because the more the rough the surface, the more there is resistance of the flow. So open channel flows are also classified as being steady or unsteady. A flow is said to be steady if there is no change with time at a given location. So if there's no change in velocity at a given location for a period of time. So the representative quantity in open channel flow is the flow depth, or it can be flow depth or the flow velocity. So if there's no change in flow depth or if there's no change in velocity, the flow is said to be steady. So otherwise it is unsteady. Okay. Flow in open channels is also classified as being uniform or non-uniform. It's also a varied flow. So depending on how the flow depth, the distance, the distance, the depth is the vertical distance from the free surface to the bottom of the channel. So depende na sa flow depth, we can consider it as uniform or non-uniform flow. The flow in a channel is said to be uniform if the flow depth remains constant. So otherwise, the flow is said to be non-uniform or varied flow. So indicating that the flow depth varies with distance in the flow direction. So uniform flow conditions are commonly encountered in practice in long straight sections of channel with constant slope, constant roughness, and constant cross section. So if the channel has this characteristic, constant slope, constant roughness, constant cross section, so most likely constant sa ang iyang flow. So constant ang iyang Q. So Q1 is just equal to Q2 or Qn, depende kung what point ang i-consider. So in open channels of constant slope, the constant cross section, the liquid in open channel constant slope and constant cross section, the liquid accelerates until the head loss due to frictional effects equals the elevation drop. So as I've said, the flow is a balance between the gravitational due to gravitational effect and the flow resistance. So there will be a time nga mag-equal sila. It's called the terminal velocity. So constant na ang iyang velocity. So the uniform flow is established. The flow remains uniform as long as the slope. So manay ganina, kung constant ang iyang slope, constant ang iyang cross section and surface roughness, so remain unchanged, so most likely the flow will be uniform. So flow depth in uniform flow is called the normal depth y sub n, which is an important characteristic parameter for open channel flow. So mo ni siya ang normal flow y sub n. Okay, so a typical representation of different kinds of flow. So we have a channel that encounters, or there is what we call a sudden drop, sudden change in elevation. So prior to that elevation change, the flow is uniform in upstream, and then as it approaches the drop, it will become gradually varied flow. So mukalit na siya og kusog, and then it's the rapidly varied flow, and then paspas man na iyang velocity, then at some point mokalit og hinay ang iyang velocity. Diba, we know that Q is equal to area times velocity, so it means that the area is inversely proportional with the velocity. So the greater the velocity, the lesser the area. So that's why if there is a change in velocity, mo kusog ang iyang velocity, so mo gamay ang iyang depth. So mo gamay ang iyang depth, it means nga ni gamay ang iyang area. So kung modako ang velocity, if there's an increase in velocity, there will be a decrease in area. So in this case, this portion, this is what we call the hydraulic jump. Hydraulic jump. So this hydraulic jump phenomena occurs when there's a sudden change in its velocity, or what we call the sudden decrease in velocity. So if you can observe, paspas kining velocity diri, the velocity is comparatively bigger as to this portion. So paspas ang velocity, then naman siya gitawag og change in momentum at this portion, mokalit siya hinay. So mokalit og hinay ang velocity, so naay increase in height. So nakay mokalit og hinay ang velocity, there's a sudden decrease in velocity at this area. So nakay sudden increase in area, so ano mokalit og saka. So nang tawag og hydraulic jump from this depth, mokalit og saka ang depth, and then going downstream it will again normalize. Mo kuan naman na siya, mo equal naman, mo mabalik naman siya sa iyang terminal velocity. So going downstream, so muubos na sana siya. So maura na ang iyang sudden change in its depth. So siya is a hydraulic jump phenomena. So like pipe flow, open channel flow can be laminar, transitional, or turbulent depending on the value of the Reynolds number. So we know that the Reynolds number in a previous discussion, it is expressed as the density. Reynolds number is a function between the density, the velocity, the diameter, and the dynamic or kinematic viscosity. So in an open channel, instead of considering the diameter, we will consider the hydraulic diameter or the hydraulic radius. So hydraulic radius is this one, RH, is a ratio between the area. This is the area. So if you have this channel, na imong channel, so this is what we call the weighted perimeter or length na nabasa. Weighted perimeter. Ano siya? Then this is the cross-sectional area. So muna siya ang perimeter, ano siya ang area. So hydraulic radius is the ratio of the area and the perimeter, hydraulic perimeter. So in an open channel, the threshold between laminar, transition, and turbulent is this one, 500. Diba in pipe, it's 2,000. Yeah, 2,000. The reason for that is because the hydraulic radius of an open channel is 4 times lower than the hydraulic radius of pipe. So that's why its value, its threshold value is also 4 times lower. Instead of 2,000, so 500 here. If it's less than 500, it's laminar flow. So between 500 and 2,500, it's transition flow. Kung above 2,500, it's turbulent flow. It's greater than 2,500. Also, by the way, laminar flow in an open channel is very rarely encountered. So dili kay na siya mahitabo. Mahitabo lang na siya. In most cases, laminar flow is encountered when thin layer of water, such as rainwater draining a road or a parking lot or a similar situation. It flows at a very low velocity. So mao na siya ang in most cases laminar flow. But in other flows such as channel flows or flow in culvert pipes, so in a flow in a river, so dili kina mahitabo ang laminar flow. Turbulent flow na siya kasagaran. So in an open channel, flow is also classified as subcritical, critical, and supercritical. So the determining factor for that is the Froude number. So this is the Froude equation. velocity over the square root of G over LC. LC is the characteristic length. LC is taken to be the flow depth Y for rectangular channel. The flow number is an important parameter that governs the character of flow in open channels. The flow is classified as subcritical if the flow number is below 1, critical if it's 1, then if it's above 1, it's supercritical or rapid flow. So the reason why we need to classify the flow, because there are topics that the classification of flow is important. So as much as possible, we need to keep the flow critical or subcritical or below critical, because supercritical flow um, has a lot of energy in it. So as much as possible, in an open channel or in our hydraulic structure, we must see to it that our flow in most, not all the time, but most of the time, in most cases, we must see to it that our or the flow in our structure or the flow affecting our structure is uh, minimum as much as possible, because for the reason um, high velocity it packs a lot of energy, so as much as possible we need to have minimum energy as much as possible nga mo impact sa atong structure. So that's the reason why if you can see marine structures na yung mga retaining wall or sea walls, as much as possible magbutang taan na og um, energy dissipators in order to minimize the energy of the waves acting on our flow. So kung makakita ta og dams or channels na located in steep slopes, so butangan nato na og energy dissipators or ato nang butangan nato na og gradient o butangan nato na og steps ang iyang flow. For example, naa kay flow sa channel nga ina na siya, so as much as possible di ta ganahan nga kusog kayo ang flow sa water, so butangan nato na og ato na butangan hagdan-hagdan para ang flow sa water hinahinay siya. Daghan mo na siya effect to avoid scouring, to avoid the damage of our structure, then to avoid the damage of the structure downstream. So daghan na siya, I think dili na nato ma-discuss tanan sa hydraulics. Adto na na sa maybe hydraulic structures or mga sa inyong major subject if you will choose to select the track in hydraulics. So adto na na siya ma-discuss and the interaction between the energy of the flow and your hydraulic structures. So mo ni siya ang determining factor, the Froude number. So consider the flow of a liquid in an open channel of a cross-sectional area and volume flow rate. So actually in this book nga akong gibasihan for this slide, the Q, ang iyang Q is ano siya, di ba? Q is area times velocity. Q is the discharge. Ang iyang symbol instead of Q, it's ano. So this equation is actually critical depth is equal to Q G square niya. Actually this equation is just equal to critical depth is just equal to V squared over G, di ba? So because Q over A is just equal to velocity, so nana siya equation. This is for the general geometry. For rectangular channel, rectangle siya, so y sub c is just equal to Q squared G niya. Rectangular naman siya. So, inala na to nga B. Ang width sa channel. Niya, 1/3. Okay. So, the depth is the liquid depth if y is greater than yc for subcritical and y is less than y sub c for supercritical. So mao ni siya ang kining critical flow, mao ni siya ang limiting factor. Kung greater gani ang iyang depth, actual depth, so it's subcritical. Kung less than gani, meaning gamay kay siya og y, meaning gamay kay siya og area, so kusog kay siya og velocity. So it's supercritical. So, mailhan na to. Kung kusog kayong flow, di ba? Kusog kayong flow, mabaw ang flow. Kay kusog man kay siya og flow. So, manang super critical. Tako siya velocity. The total mechanical energy of this liquid in the channel in terms of head is expressed as the sum of the potential and the kinetic energy. So, if you can recall the Bernoulli's energy equation applied to pipes. So, same ra gyapon na siya. As I've said, we still use the same concept. But ang nakalahi lang, in this case, is wala na siya pressure. Wala na siya pressure. Ang pressure, instead of kini pressure, giilisan siya og depth y. So, nagyapon tay elevation, nagyapon tay energy, kinetic energy, the energy of the velocity, so v squared over tau g. The total mechanical energy of the fluid in terms of heads becomes the sum of the pressure of the dynamic heads. Okay, so the sum of the pressure and dynamic heads of the liquid dynamic channel is called the specific energy, ES, mani siya. So, mani siya ang specific energy of the flow. So, Y V squared over 2G is the depth and the velocity. An example, okay, I will just end this video here. Then, we'll just continue with the video of the examples para dili kay siya taas itong putol-putulon. Okay, that's it for now. So I will continue with another video.